So continuing the lesson on general angles in radian measure. The example, find one positive angle and one negative angle coterminal with the given angle. So you could pause this presentation and try these two problems. You should have a total of 4 answers, a positive and negative angle that's coterminal with 210, and a positive and negative angle that's coterminal with 420. So for 210 degrees, I can obtain a negative angle that's coterminal with 210 by subtracting 360 from 210. That gives me an angle of negative 150 degrees, which is coterminal with 210. If I add 360 to 210, that'll give me an angle 570 degrees, a positive angle that's coterminal with 210. For the second problem, for 420 degrees, well, to arrive at a negative angle coterminal with 420, subtracting 360 won't work because that'll still be a positive value. So I need to subtract a greater multiple of 360. 2 times 360 will work. 420 minus 2 times 360, which would be 720, will give me a negative angle, negative 300, which is coterminal with 420. And then to get a positive angle coterminal with 420, well, if I just subtract 360 from 420, that'll give me a positive angle coterminal with 420. These are just examples of angles coterminal with 420, and in this case, these two angles coterminal with 210. But there are an infinite number of angles that are coterminal with 210 and an infinite number of angles that are coterminal with 420 because I can add or subtract any multiple of 360 to arrive at an angle that's coterminal with 420 or 210 or any other angle measure I'm given. So up to this point, we've been looking at angles measured in degrees. There are other units to measure angles, and one of the most common is the radian. So I can measure angles not only in degrees, but in radians. And the last sentence here defines a radian. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc length of r, which is the radius of the circle. So looking at the figure, this angle that's indicated here with this red direction arrow, that's positive 1 radian. It's positive because it's counterclockwise rotation. But it's 1 radian because the radius of the circle and the intercepted arc, this arc that's intercepted by the end of the initial side and the end of the terminal side, that intercepted arc has the same length as the radius of the circle. When that's the case, the measure of the angle is 1 radian. So oftentimes we need to convert angle measures from degrees to radians or from radians to degrees. And the relationship that we use is that a full circle, 360 degrees, in terms of radians, that's equivalent to 2 pi radians. If I take that equation and divide both sides by 2, I get the relationship that 180 degrees is equal to pi radians. And I can use that fact to convert angle measures from radians to degrees or from degrees to radians. So here in the figure you see several common angle measures indicated in both degrees and radians. So for example, a 60-degree angle is equivalent to pi over 3 radians, or a 30-degree angle is equivalent to pi over 6 radians. To convert, you can see an example here on the right-hand side. If I start from an angle of 30 degrees, to convert to radians, I multiply by the conversion factor. Pi radians is equivalent to 180 degrees. By writing the conversion factor with radians in the numerator and degrees in the denominator, I can convert from degrees to radians because when I multiply, degrees in the numerator will cancel with degrees in the denominator, and I'll be left with an answer in radians. 30 degrees is equivalent to pi over 6 radians. To convert from radians to degrees, starting from an angle that's measured in radians, 180 degrees is equivalent to pi radians. This time the conversion factor places 180 degrees in the numerator, pi radians in the denominator. Now when I multiply, radians cancels with radians in the denominator. I'm left with degrees in the numerator. And the result here, the pi's cancel. I've got 180 degrees divided by 6, 30 degrees. So to rewrite a degree measure in radians, multiply by pi radians over 180 degrees. To rewrite a radian measure in degrees, multiply by 180 degrees divided by pi radians. Those are the conversion factors we were just looking at. So once again, a couple of examples. Converting 320 degrees to radians, I multiply by pi over 180 and simplify the fraction. Get 16 pi divided by 9 radians. To convert from radians to degrees, I multiply, in this case, negative 5 pi over 12 radians times 180 degrees divided by pi. Simplify the fraction, the resulting value is negative 75 degrees. If you notice in the first example, there are no specific units indicated. In other words, I don't write out the word radians. If you write an angle measure with no units indicated, the assumption is that you are measuring that angle in radians. So if you mean degrees, you need to indicate degrees. If you mean radians, you don't need to indicate any specific units. So in this example, we write each degree measure in radians and each radian measure in degrees. So on the following slide, you can see once again 160 degrees converted to radians by multiplying by pi over 180. Pi over 10 radians converted to 18 degrees multiplying by 180 over pi. The last part of this lesson, we're going to look at arc length and the area of a sector. So here you can see what they mean by the sector of a circle or a sector of a circle. I'm going to stop this recording now and continue this last part of the lesson in a third video.